Ooh, we got to do some extra maths here. So the waveform, this whole thing here is 2.42 meters long, right? Right? Okay, so we want to find the wavelength, and then we want to find the frequency. Okay, so we're going to find the wavelength, and we're going to use this formula to find the frequency. So the first one is what L is n lambda over 4. So how many quarter wavelengths? Well, there's one quarter wavelength here, right? So I'm going to go 2.42 is 1 quarter wavelength. So the wavelength is actually, what, 4 of those, right? 2.42 times 4. The wavelength is 9.68 meters. That's our first answer, right? And then let's use V is F lambda. Let's figure out the frequency, right? So our velocity is 343 is equal to frequency that we don't know times 9.68. So I'm going to divide. I'm going to go this divided by that. And I get 35.4 hertz, which is a really low note. Okay, but it actually is a note, and what's cool about this is that this is pipe organ pipes. If you're into pipe organs, right, they are actually like this. They've got, it would be tipped up. This would be the top of it, right? Those pipes that look like flutes and they're square on a pipe organ that have a little notch in them in the top, those are actually fixed on the bottom. They're like a pan pipe. And the cool thing is you only have to put a quarter of the wavelength in the pipe. So the pipe, the longer the wavelength, the lower the pitch, right? So to get the really low notes, you can use these pipes and they can be a quarter the length of another pipe or half the length of another pipe. And they can get a really low note because you can get so little of the wave in there. And what really happens is that the wave is, since it's a longitudinal wave, it actually moves back and forth like this. It doesn't move up and down. But anyway, yeah, that's cool. Maybe you didn't think it was cool, but I think it's cool.